afternoon, good evening, guys. Today we are starting a new chapter in physics, that is light, reflection, and refraction. Okay, let's going into the concepts. Let's just overview our chapter. Okay, in this chapter we have to know what is light, what is reflection, what is refraction. Okay, in that the first video is dedicated that light, what is light. Okay, we are going to learn what is light in the first video, and the second video we are going to learn what is reflection, surfaces, and the logic, how light interacts with surfaces, and law of reflection. In that, mirrors, plane mirrors, spherical mirrors. In the spherical mirrors, types concave, convex. Okay, after that we are going to learn the terms used in this. Okay, after that the light interaction with plane mirror and what are the images formed there, and after the spherical mirror, next ray diagrams, next mirror formula and its derivation. Okay, for deriving mirror formula we are going to learn a simple concept, that is similarity, which you have learnt in ninth class. It is congruency. In the same way, there is a concept called similarity, and I am not going through everything in the similarity, just a single thing I will be saying you. Maybe in 1 minute the concept may complete. Okay, no problem. Next, numericals and problem solving questions will be in video 7. We will having problem solving over there. Next, in video 8 we will go for refraction. In that, what are the mediums and types of mediums, what do you mean by refractive index, types of refractive index, what is the speed of light in vacuum and everything. Okay, and its interaction. Here also I will be telling you logic, how it interacts. Okay, and about Snell's law, total internal refraction, ray diagrams, and where there it is mirror formula and its derivation, right? In the same way, here we are going to learn lens formula and its derivation. Okay, after that we will be having our numericals and problems. This is the agenda we have. First video is going to be what is light, right? So let's dive to the first video. Okay, what is light? Light is a thing which you see every day, right? In your home you have electric bulb, right, that emits light. In the same way, sun also emits light. First of all, what is this light? Okay, everyone says that light is an electromagnetic radiation, right? So here we are not going to learn everything about light, right? So what is very important for your examination and for quick understanding, what you need to know, that I am going to teach you. Okay, in this slide, electromagnetic radiation. What is electromagnetic radiation? First, let's learn what is radiation. After that, what do you mean by electromagnetic radiation? Okay, what is radiation? That which is radiated. That which is radiated is called radiation. Radiated in the sense released, or we can say spread. Actually, released is not a good term for this. The better one is, we have to use the better word, spread. Spreading of something from a point source or whatever the source it may be. If you see sun is a source from which light gets spread, right? So light is an electromagnetic radiation, that is, it is a radiation. First of all, it is radiated from the sun in all the directions. Okay, from the sun it gets radiated and it reaches different planets, right? What are the planets in the solar system? There are different planets in the solar system, including Earth. So each and every planet gets its radiation from the sun, because it is emitted from the sun and it gets spread from the sun, that is radiated from the sun. So anything which gets radiated is called a radiation. Okay. See, after that radiation, okay, we learned the radiation. What is electromagnetic? Actually, this is not a concept which you have already learned, so I don't want to go inside it, because while telling about the electricity chapter, while we go through the electricity chapter and while we go through the magnetism chapter, what we have in the 10th class, that is effects of magnet, right? So, magnetic effects of electric current is the chapter and electricity is another chapter, right? There we go and learn something which is related to the electricity and magnetism. Okay, so till now you don't have an idea about electromagnetic thing, right? That's why I'm not going here. If anybody wants to know what is electromagnetic radiation in full, why it gets causes each and everything, I will put a video separately. Okay, so here we are going to learn what is radiation. Okay, radiation is completed. That which is radiated, that is spread. We can also say another term for spread is propagated. Propagated. It also means spreading, right? This is sun. Okay. The radiation gets spread like this. For first few seconds, it goes chill here. After that, it goes like this. See here, what it is forming here, it is nothing but a wave. So, light is a wave. Up to now, let's understand that it is a wave. Okay, there is a quantum mechanics thing here, that a light also behaves like a particle and wave. It has a particle wave duality. We are not going to quantum physics now. Okay, quantum mechanics now. So it is propagated as wave. So it is propagated as wave. These wave contains electric fields and magnetic field, both electric and magnetic. Okay, by this its name became electromagnetic radiation. Okay, so let's go a simple logic. Okay, if anybody has an curiosity to know how does this happen. Okay, for just curiosity. Okay, see, this is going to be the electron. Okay, the electron has its own field like a magnet. Okay, if there is a magnet, will the magnet effect has only to a direction? No, right? That is, if any iron nail or something kept in this direction only, if it is only having its power to pull such an iron nail on anything, only up to this direction only? No, right? Only up to this direction only? No, right? Only this direction? No. Only this direction? No. Because it has its radial power. Okay, power in the sense it has its effect radially. Its field is going to be radial thing. If you have a magnet like this, if you keep an iron nail on top of it or above this magnet also, it attracts the iron nail, right? So in all the direction, it is the electron. So we have in all the direction its field. Okay, that is its power or its effect to pull such an iron nail or whatever it may be, which is in that magnet, a magnetic field. In the same way, electron also has its radial electric field. Okay, radial electric field. And electron has a intrinsic property called spin. Spin means not in traditional sense that there is a ball, it spins. Here spinning means what? This side of ball gets turned into that side and the back side comes front, and it gets rotating like that. Okay, that is called in traditional spin. Okay, here, why we call here spin in a normal ball or whatever it may be, because it has its volume, because this volume is made up of small particles or atoms, so it has its volume, so here it spins. Okay, because it has a face like this, it has a dimension like this, a separate face, it has a separate face or dimension like this, which spins because it has volume, right? It has a volume, it has a size. Okay, each and every atom is different and separate in that volume thing, and by spinning here, each and every atom, the atom where it is present here, moves in this direction or in this direction during a spin. But here, when it comes to an electron, it doesn't have a volume actually, because it can't be divisible. It doesn't have a volume like that. It is very point sized one, right? So it is not made up of anything, like here in this ball or whatever it may be, a circular object where it spins. So here we can't say the spin like a traditional sense, but it has an intrinsic property called spin. Okay, here it is not spinning or rotating, but it has a property called spin. Okay, due to the property, whatever here ball spins, right? In the same way, it also has the property of spin. By that, the electric field around the electron also spins. Here, the electric field has volume, radius. It is spread across the electron in a radial path, right? So here this electric field spins. Okay, a spinning electric field like this, spinning electric field. Okay, when the electron is stable, when the electron is stable and electron has its spin, here the electric field also just spins. Okay, electric field just spins. What if electric field moves? That is, what if electron moves? If electron moves like this, the spinning electric field also moves. Spinning electric field, if it doesn't move, it only spins like this. So we don't know is it spinning or not. We can't find whether it is spinning because it is stable at a single position. But when it's moving, the spin is visible like this, like a spiral thing. Okay, so here the electric field, while the electron moving, the electric field spins like this, which is visible like a spiral one. This spinning electric field is called a magnetic field. Okay, spinning electric field is called a magnetic field. Okay, here electron doesn't have volume. It doesn't have volume, so it can't spin. In the sense, in the traditional sense, it can't spin, but it has a property which we call it as spin. Okay, so it doesn't spin, but the electric field around it spins. Due to the intrinsic property of this electron spin, it gets spins. So the electric field spins. When the electron moves, the electric field also moves. The spinning electric field changing its path can be observed in the form of a spiral thing, which is called as magnetic field. A magnetic field is that thing which revolves, or which we can say it as which moves in a spiral path across electron. If it is an electron, if it is moving here, it goes here. So the electric field spins like this. Actually, the electric field is going like this only. See, this is the electron and this is the electric field. Okay. When electron goes like this, electric field will be here. But due to its spin and due to the moving of electron, that spin here creates a spiral thing, a different loop and a different power or a different force is provided due to the movement of electron called as a magnetic field. Okay, here electron moves in this direction means the field will be around this in this direction, that is in perpendicularly. So electric field is perpendicular to magnetic field. And now we have learned how this magnetic field comes due to change in electric field. Actually, this is not a perfect thing. Okay, not change in electric field. For your understanding purpose, I have told like this. But exactly if you want to say due to movement of electron, it creates the magnetic field. And we can also say that due to change in electric field, it induces a magnetic field. Okay, next see here again. Due to change in electric field, there is a creation of magnetic field. Okay, see here. Electric field is going to change here while moving due to the electric field spins. Actually, yes, electric field spins. Due to this, a spiral thing forms, that is magnetic field. What if here electric field got changed, so it induced a magnetic field? And here again I am telling you, okay, again I am telling you, electric field is perpendicular to magnetic field. Electric field is perpendicular to magnetic field. Here, okay, come here. What if the magnetic field changes? There is a constant magnetic field following an electron due to the movement of electron. Okay, here there is a constant magnetic field. Before this, when an electron at rest, there is a constant electric field. Constant electric field is there. Due to movement of this electron, it created a constant magnetic field. It created a constant magnetic field. Okay, after this, what if this constant magnetic field gets changed or gets varied? Okay, if this constant magnetic field gets varied, what happens? If this electron like this, what creates the change in magnetic field? First of all, what created the change in electric field? Here electric field is dependent upon electron due to change in the motion of electron. Due to change here from rest, it has gone to some velocity. Okay, due to that movement of this electron, there is a change in electric field which induced the magnetic field. Here magnetic field is dependent on electric field, right? If there is any acceleration in that electron, if electron moving with same or constant velocity, it causes a constant magnetic field. What if electron accelerates? What if electron accelerates? See here. If electron accelerates, if just it moves like this, we have spirals. If it moves in the same velocity, we will be having spirals here. What if it accelerates suddenly? If it accelerates, so here the change in this magnetic field will be seen. See here, there is a constant loop, but here due to the change, this loop gets changed, right? This loop gets changed. See the size of this loop. This loop gets changed. So suddenly due to the acceleration of electron, this releases a radiation from such magnetic field which is perpendicular to the magnetic field. So there is a radiation because due to sudden change in the velocity, sudden acceleration, there is a change in magnetic field. Okay, there is a change in magnetic field which disturbs the space fabric. That is the space around it. So due to the disturbance in the electric field, that is change in electric field, its perpendicular thing, that is magnetic field, has been erased. In the same way, when there is a change in the magnetic field, its perpendicular thing, electric field, gets induced here. So even without the electron there, this magnetic field with some force produces a perpendicular electric field. Okay, in the same way, when you see in sun, it has higher temperature. Due to higher temperature, each and every atom becomes plasma. Okay, each and every atom in which there is a nucleus and around there are electrons, right? Here it is firmly packed. Due to higher temperature, it becomes plasma. That is, nucleus becomes separate, electrons become separate. Even in nucleus, protons become separate, neutrons become separate. They will be floating like swimming in a river. Okay, they will be floating like that, like this. They will be floating. At this high temperature, the electron gain heat, that is energy, and it accelerates faster. Okay, and it accelerates faster. Due to this acceleration, actually electron moves even in an atom at low temperature also. Electrons just moves in its orbitals. Then moving electrons have its own magnetic field, right? Here it is becoming plasma and it's accelerating. Due to acceleration, a perpendicular force to the magnetic field arises that is equivalent to the a field which arises perpendicularly to the magnetic field, that is nothing but an electric field. That is, a field which is parallel to the electric field is nothing but here electric field, because there are only two fields over there. One is an intrinsic property of electron or proton. Even proton has its electric field, but in a different direction, that's it. And a perpendicular thing to the proton or electron, whatever it may be, the electric field, if perpendicular field perpendicular to electric field, is termed as a magnetic field. If there is any field which is perpendicular to magnetic field, that is nothing but electric field, because if electric field is perpendicular to magnetic field, and if magnetic field is perpendicular to some other field, that is nothing but electric field and that field are parallel. Okay, no two fields exist parallelly. Okay, here field here is Here we are talking about the basic thing. Okay, here in normal world we have everything differently, but when according to the field, that is a force against a direction or a dimension. If a force is against this direction, okay, whatever the force around this direction is same, the intensity becomes higher or lower, that's it, but these two forces are same. If there is a force over like this, these forces are same. Okay, so if I have termed it as an electric field, then which is perpendicular to this electric field, I have termed as a magnetic field. Again, which is perpendicular to magnetic field is nothing but an electric field. Okay, in the same way, due to the change in magnetic field, that is due to the acceleration of electron, it induced a separate electric field. So chain reaction, due to this chain reaction, electric field transformed into magnetic field, again this transformed into electric field, again this transformed into magnetic field, again electric field, again magnetic field. By here from an electron, we are getting electric field. Due to the acceleration of electron and due to the moving of electron, we get magnetic field, right? From this magnetic field, here we have electron in existence. Electron in sun we are talking about here exists. Okay, and here this radiation, whatever these fields are existing in sun only. After this, due to the acceleration, it created an electric field. Due to acceleration, it created an electric field which is also accelerating. That is, electric field is changing, which induces the magnetic field. Okay, due to accelerating of electric field, it induced an accelerating magnetic field. If there is an electric field which is moving, it creates just a magnetic field. If it is electric field is accelerating, it creates an accelerating magnetic field, right? That is, there is a change in magnetic field also. So this converted again into electric field. This is also accelerating. This is converted into magnetic field. This is also accelerating. This is converted into electric field. In the same way, it is a sun. So it radiated these fields. First electric field, next magnetic field. There is changes in electric field, magnetic field, electric field, magnetic field. This is called as electric field, magnetic field, electric field, magnetic field, electromagnetic spectrum. Spectrum is nothing but a visual thing or whatever it may be. Here you see electromagnetic, 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 electromagnetic thing. So this is our spectrum, and it is propagated as wave, so it also can be called as electromagnetic waves. Of course, it is radiated from the sun, so it is a radiation, so it is an electromagnetic radiation. So here we learned about electromagnetic radiation. So light is an electromagnetic radiation. Okay, these electromagnetic radiation have these waves, that is electromagnetic radiation, we have these waves, right? Here this is sun. Here I have just provided you with, for your knowledge purpose, like this spirals. Okay, sun with this like this as a waves, right? Actually it is not like that. Just for your sake I have drawn like that. Okay, it is sun. Okay, here there is a point in sun. From this point some wave is coming like this. It is propagating like this. It is increasing. In the same way, there is a point here also. Here also the wave propagates like this. See here, one wave is colliding or intersecting another wave. In the same way, sun has infinite points, infinite atoms will be here around the surfaces. Okay, each and every atom gets accelerated. Each and every atom, due to its acceleration, its magnetic field also accelerates. So it induces magnetic field, changing electric field, changing magnetic field, change in electric field. So from each and every point we will be having a propagating wave. So if it like a wave like this, some other waves will be colliding with this. So if you see single wave like this, it will be colliding like this. Okay, like this the wave appears. Okay, here whatever the wave intersecting with another wave is there, this intersection point which we see as light rays. Light rays, because light waves cannot be viewed as a ray. Okay, due to this intersection, movement of this intersection like this. See, like this. Okay, there. See, there is a wave. I am not drawing a circular wave. Okay, if you see a wave like this, if it is intersecting with some other wave like this, you see this intersect point. Okay, if it moves like this and it moves like this, see this intersecting point. This intersecting point is also moving like this, forming a straight line that looks like light rays, which our eye see it as light rays. Okay, visually, why? Due to the intersection or collision of these electromagnetic radiation. That is, here two different electromagnetic radiations, that is two different electric field or magnetic field getting intersected. Okay, which we see as light rays. Again, another thing is there. Here the waves are coming. Okay, here there are different waves which comes from sun. Sun, when you see from this outer layer till its inner layer and inner core. Okay, when you see the temperature here on the surface are wholly different. Okay, at surface there may be very less or very less temperature when compared to core. When compared to core, the temperature here would be very drastically changed. Okay, or we can say there is a huge difference in temperature. So if temperature increase, the electron absorbs that temperature or that energy and it accelerates in such a speed according to this temperature, right? So here at core, if there is more temperature, that is huge or heavy, huge temperature, greatest temperatures if it has, the electrons here accelerate faster than here, right? Due to change in this energy levels here, some electrons accelerates fast enough, some faster, some bit slower. Due to the speed changes here, its electric field also, what is there? Electric field also travels, some travels faster, some slower, some bit slower. In the same way, induced magnetic field also, some travels faster, some slower, and some bit slower. Okay, due to this we get different waves. If this is sun, okay, I'm just drawing a single wave, okay? Not a colliding wave for your better understanding. I'm just taking a single wave from this point, okay? From this point, if you take in a very, because it travels in a speed of light and around speed of light, okay? Speed of light even more faster than speed of light, whatever it may be, okay? Some even slower than speed of light, faster than speed of light, it can't be possible, okay? Near to speed of light or even slower than speed of light, whatever it may be. Actually, these radiations travel at speed of light, but after one radiation to another radiation, there will be a time gap, okay? If one wave has been emitted, if one wave has been emitted, due to this speed thing, the next wave, that is when electric field gets emitted, after that, for emission of that magnetic field, there will be some time gap, okay? First, due to, if there is a very faster thing happening over there, then there won't be much time gap, that is the waves, the distance between waves will be very small. This is called the wavelength, the length between two waves, two consecutive waves, that is either two magnetic fields or either two electric fields, because how much speed the electric field goes, in the same way the magnetic field also goes. So one cycle for that electric magnetic, there won't be any change, but from one electric to another electric, there will be time gap due to the speed. One cycle is not interrupted by this, okay? So the electric magnetic, whatever is there, this thing doesn't get interrupted by that, but one cycle, then after another cycle is there, right? So here there will be a gap. This gap is called wavelength, okay? So when we talk about some time, in 1 second, okay, in 1 second, if you are seeing, for if there is any, this is sun, right? Let's take here one line. How many waves passes this line in 1 second? Okay, some may pass 100 waves, for some it may pass 500 also, some 50 also. Here that means in 500 here, the light rays are said to be passed very fast. Okay, in this such a time, if it is passing this distance, if this is sun, waves are emitted. If it is passing this distance in 1 second, okay, that is also 500. That is like this. 500th will be here, 499, 498, 497, 496, like this. Here will be the first one. So in this space, we have 500 waves here. If you see here, if this space is 1 meter and there are 500 in this, so 1 meter means 1000 centimeters, 1000 millimeters, divided by 500 waves, that is, there is one wave every 2 millimeter, right? So for every 2 millimeter, there is one wave, that is sun, 2 millimeter one wave, 2 millimeter one wave. So here, this 2 millimeter is nothing but the wavelength. The length between two waves, two consecutive waves, is nothing but wavelength that we have found by the distance it covered divided by its how many waves it generated, that is its frequency. That is, how frequent are those waves? How many waves are there here? Its frequency. This is the distance covered by frequency, providing its wavelength. Here we have took millimeters, right? But actually the wavelength will be much lesser value, that is in nanometers. Okay. So here, due to this, different frequency having waves are generated, that is the electromagnetic radiation with different frequencies, that is with different wavelengths, with different wavelengths. So this different wavelengths has been named different. Okay, in that these all electromagnetic radiations, some electromagnetic radiations are visible to our naked eye. Our means human naked eye, not cat's naked eye, or not snake's eye, or not mosquito's eye, etc., dog's eye, and all. Okay, human naked eye. Some electromagnetic radiations are detected by our eyes, that is called light. So light is electromagnetic radiation that is visible. In that visible electromagnetic radiation also, we have categorized into different colors, from ranging from violet, indigo, blue, green, yellow, orange, and red. So this is the visible spectrum that we see. So which is beyond this red is called infrared. Okay. Beyond this violet, it is called ultraviolet. Okay. This ultraviolet is there before violet, and even some things are there. Those are X-rays, gamma rays, etc. Here this infrared rays, we can't see it. Okay. If you have any pan, okay, if you put it on stove, it gets heated. We can't see that heat thing, but we can experience the heat. That is nothing but an infrared thing. Even human bodies has heat. Okay, that is nothing but an infrared radiation which your body is releasing. Even sun releases the infrared radiation. Infrared radiation is released by sun also. Even X-rays are released, gamma rays are released, the visible spectrum Vibgyor also released. Even some are there. Okay, radio waves are there, microwaves are there. Okay, here beyond violet, these are all the least wavelength one. That is, least wavelength means one after one waves right there, there is a less gap. That is, more waves gets generated in less time due to what? Due to excess temperature, electron gets excess energy such that it travels in fastest speed. By that, it provides this, right? So it generates the least wavelength waves. Okay. So these wavelengths has its own energy, that is the heat which it got from the electron. Okay, the absorbed heat is what there it gets absorbed. So excessive heat will have been embedded in the least wavelength waves, and the least heat is observed or it has, which has is the highest wavelength one. That's why the radio waves, though it travels even at night or at morning, they don't have heat. If it really has heat, if it really has heat, even at night also we will be feeling the heat. But night it will be cool, right? Next one. This is the thing which we have to learn about light. Okay, each and everything has been completed regarding light. So there is a small part which we will be discussing it in the next chapter, that is human eye and colorful world. So till here